give me a date that I have or will hit right now, regardless. I don't want anything that's going to be a second from now or a millisecond from now. I want something that when I pass it in means has already happened. And
the main reason you use either of these in the first place is kind of for times when something needs a time but you don't really care what time it is. They say that using distant past is using some kind of boundary time that you know you'll never be less than. Just to kind of bound the time that you're running things on.
Because you can compare dates. There's methods for comparing dates in NSDate. So date by adding time interval is a instance method version of date with time interval since now. The earlier date and later date allows you to compare two dates so that you could say now and I want another date with that's 60 seconds from now, and then I want to compare those. I want to continually compare those two dates. The reason that you use NSDate is not only is it an object, since you can use it as a key or put it in sets or arrays or other collections, but you can also I had this on the tip of my tongue. There's a very good reason for having these objects.
Date formatting?
Yes, date formatting, thank you. You're guaranteed that this will work across having different calendars. So if you're running a non-Gregorian calendar and you specify 60 seconds from now and you are 30 seconds from midnight of January 1st of year OX3A4, then you're guaranteed that it's going to give you back a correct date that you can compare to that will be 60 seconds from now, even if under the hood there's a lot of complicated math to calculate differences in dates. Earlier date and later date are the two methods that you can use to compare two dates, and it returns you back which one is earlier or which one is later. If you want to know the time difference between two dates, like let's say you set one 60 seconds ahead and you want to know the date, the time now, and then the time now, and the time difference now, and the time difference now. Look in the documentation. There's NSDate has a whole bunch of handy utility methods that you can compare and subtract off of dates or add dates together or put them in your collections. Let's see. Oh, that's right. Okay. So those are collections. Those are some convenience methods in the foundation classes. Any questions before we jump into the next section? Okay. So this requires a little bit of attention. This typically is one of the more difficult concepts to grab a hold of and really understand. I'm going to try and not speak down at all, but I am going to take my time here because this seems simple enough on the surface, but then once you start practicing it, it can quickly become voodoo that doesn't make a whole lot of sense. It's the reason for automatic reference counting, which will be great if it works and you've got iOS 5 or OS, or you running on Lion, awesome, and hopefully it works great. But understanding how all of this works is really key and is really critical. So, memory management under Objective-C is akin to C's malloc and free. Java uses garbage collection. You don't specifically allocate objects outside of using things like new. You don't have to actually delete objects or free objects. You let the Java virtual machine handle that for you. Objective-C uses a thing called reference counting. Has anybody taken compilers or heard of using reference counting for memory management before, prior to this?
If you have, you've probably heard that it's a bad idea.
Right. So, here's the lowdown. Every single object has got a reference count associated with it. This is one of the reasons that these are pointers, too. The methods, the class method alloc and the instance method copy set the reference count to 1. So when you allocate a new object, or when you make a copy of an object, its reference count is 1. What it starts out with. You can call retain and release on that object to increase and decrease its reference count. And we'll see why you would want to do that here in a second. Once the reference count has reached 0, then Objective-C actually frees your object from memory. So, alloc or copy sets the reference count to 1, retain increases it, release decreases it. When it hits 0, the memory is actually freed and released. So, here's the rules. Alloc, copy, and retain have to be followed with a release. Alloc, copy, retain, followed with a release. So they work hand in hand. It's a partnership. If you have multiple retains, on an object, you need the exact same amount of releases on that object. Alloc, copy, retain. Alloc, copy, retain, alloc, copy, retain, alloc, copy, retain. Emit is not on here. New thing with thing is not on here. Alloc, copy, retain is a release. Yes?
Does copy actually create a separate copy, or is it just give another copy to the same thing?
It creates another copy. It allocates and creates another copy. And we're actually going to get to that towards the end when we talk about properties. We'll talk about that exact same thing. And if you still have questions about it, ask me. Okay? So, here's the broken down to its most fundamental. You've got an object called myObject. You allocate it, which does what? Increases the reference count and sets it to 1. Init, what does that do to the reference count? No, could do something under the hood, but we don't assume it does anything. We assume that allocate sets the reference count to 1. We do a bunch of stuff with the object. We pair it with release. Seems simple enough, right? Allocate, release. Here's the other method that requires a release. Copy. So we've got an object. We call other object copy. It gives us a copy of this other object, which means allocate memory for it and fill it in with the same values. That requires a paired release with the copy. So we've hit allocate and copy so far. Yes?
So when you copy it, let's say you copy an object that has objects as instance variables that are objects.
That are pointers.
Will the person who copy those objects as well, or just copy the pointers? Or I guess they are pointers, so just copy the pointers.
Yes. And
Well, by default, copy is actually not defined. The default implementation of copy in MSObject actually throws an exception. So if you want an object to actually be copyable, you have to implement a copy method.
So we're going to talk about that towards a little bit later too. But that's an excellent question. Yes?
Is there a time when you want to leave memory?
Only if you were doing some hacking and you wanted to, say, pass data between apps, you might want to do that, but there's really no good reason.
Because, like, for our chat box,
Yes.
we were doing retain without string, right?
Well, we were doing that because I didn't teach memory management yet, and we wanted to make sure that string didn't disappear. And we'll explain in a little bit why it might have disappeared.
Okay.
All right. So yeah, hold on to that and ask me again if the next couple of slides if it's not clear. Okay. So my object. We call this controller. We just say controller. Give me a reference to my object. We probably haven't set up a property, a getter and setter for this, so we're not using the dot notation. So we're saying, okay, give me a reference to my object. We get a reference to it. No release. Allocate, copy, and retain. What if we want to hang on to it? What if we want to make sure that it doesn't get released out from underneath us? That's our third case. Object. We ask this controller. The target is controller. We ask it for my object. We get an object back. We call retain, which gives us ownership of it. That means that if anybody else releases it, it doesn't matter. We've increased the reference count, so if they have correctly paired retain and release counts, we're always going to be +1 from them. We can do our work, followed by release. Allocate, copy, retain. Here's another example. Say we actually want to mutate a copy that comes back out. We ask the controller for my object. We call the copy method, which is one of our three. We can mess with the object, and then we want to call release. Is there a question back there? Yes.
What is controller?
I'm sorry?
Controller? What is it?
He said, what's the...
Oh, what is controller? So controller is just a class of ours. It's an instance of a class of ours. I'm assuming in this example it's a NS controller or NS window controller. It doesn't matter for these purposes. It's just it's the target object, and when we say give me my object, we get an instance variable out of it. So it's just an instance of an NS object, or an instance of a subclass NS object. Okay? So, reference counting. So, Fido, the dog, we allocate the dog. We have dog as one of our classes. We allocate it, which does what? Increments reference count. Reference count goes up by 1. Init, whatever, doesn't matter. Allocate. So allocate has got a reference count of 1, and it's a leash on our dog. So Fido is the name of our variable, of our instance of dog. We call Fido retain later on. We now have 2 retains that have been called on Fido. So let's say this original. We've got up in the original code, after we've allocated Fido, we've done some stuff with it, and then we call release. This no longer has control over it, but since we called retain back here, we still have a reference to Fido. Fido doesn't go away. Fido isn't deallocated when you call this release. To make him go away, you have to call release again, and he's gone. Does that make sense? So everything's all balanced. You always want to make sure that these are balanced. Balanced calls to alloc or copy or retain are always balanced with the release. Questions? Okay, so style guidelines say that when you have a function like a factory method or a factory function in C++, if you allocate it and you return it, that you shouldn't be requiring the person above you to know anything about your memory management, so you shouldn't be requiring them to free or release your object. Unless you've implemented an alloc or a copy or a retain, overridden retain somehow. This doesn't make sense. Unless you've written your own copy or alloc. you shouldn't be expecting your callers to know that they have to call release on your object. Just like in C, if you